A given volume of methane diffuses in 20 seconds. How long will it take same volume of sulphur oxide to diffuse under the same conditions, given the atomic mass of carbon to be 12, hydrogen 1, sulphur 32, and oxygen 16? Solution. Before we proceed, if you are yet to subscribe to this channel, please do well to subscribe and click on the notification bell as well, so as to get notified and get more of these videos. Now let's continue. For diffusion of gases, the law applicable is the Graham's law of diffusion, which states that the rate of diffusion of gas is inversely proportional to the square root of its density. And in cases when we have two gases involved, we have Graham's law equation to be given as R1 over R2 to be equal to square root of the molecular mass of the second gas divided by square root of the molecular mass of the first gas. Here, subscript of 1. Subscript of 1 and 2 refers to the first and the second gases respectively. So now the first gas here is methane, while the second gas will be taking that to be sulphur oxide. We've written out the formula we'll be using to solve this question. Then the next thing to do is to write out the values given from the question. Let's start with the rate of diffusion of gases. For R1 is equal to R subscript of CH4. That is the rate of diffusion of the first gas, methane. Now for rate, rate is given as volume over time. So now for rate of diffusion of methane, now we have that to be equal to the volume of methane gas. So let's say volume over time. And that is equal to the volume of the methane gas is not given. We are being told that the given volume of methane diffuses in 20 seconds. So since the volume of methane is not specifically given, then we can just take that to be, let's take the volume of methane gas to be V. So we have V centimeter cube divided by 20 seconds. So we'll be taking RCH4 to be V over 20. Now let's move on to the second gas now. The rate of diffusion of the second gas, which is sulphur oxide. We have RSO2. So when I said same volume diffuses under the same condition, we have volume over time. So here now, since it is same volume, we'll be having V as well, V centimeter cube. And for the time taken is unknown, so we have that to be T. So now we've gotten the rate of diffusion of the first gas and the rate of diffusion of the second gas. Now let's move on to the molecular mass, the relative molecular mass of the gases. For the first gas now, M1, that is the molecular mass of methane, we have that to be the sum of the atomic masses of each element present in the compound. So now we have carbon first, and the atomic mass of carbon is 12, so we have 12 plus. That of hydrogen is 1, and we have 4 atoms present, so we have 4 times 1. So this gives 12 plus 4, which is equivalent to 16 grams per mole. So for M2 now, that's the molecular mass, the relative molecular mass of the second gas, which is sulphur oxide. We have MXO2. That will be equal to, we have sulphur present in it, that's the atomic mass of sulphur is 32, plus oxygen is 16. So and we have 2 atoms present, so we have 2 times 16. So this gives 32 plus 32, which is equivalent to 64 grams per mole. Now we've gotten the values of R1, R2, M1 and M2. The next thing to do now is to substitute the values into the equation. Now from the formula we have R1 over R2 to be equal to, I'm writing the formula again now. We have R1 over R2 to be equal to square root of M2 over square root of m1. So now replacing this with the gases, now we have R1 to be rate of diffusion of methane. So we have RCH4 over RSO2 to be equal to square root of the molecular mass of sulphur 4 oxide SO2 over square root of the molecular mass of methane. So from the previous calculation we did, now we have RCH4 to be V over 20 divided by the division sign here, divided by V over T. Now I'm neglecting the unit so as to make the calculation easier for us, to be equal to square root of the molecular mass of SO2, which is 64, divided by square root of molecular mass of methane, which is 16. So here we have, changing this division sign to multiplication sign, we have V over 20 multiplied by T over V, which is equal to square root of 64 over square root of 16. So here now V cancel each out, then we have T over 20. We are left with T divided by 20 to be equal to square root of 64 is 8, while square root of 16 is 4. So from here now T equals 20 times 8 divided by 4, which is equal to 160 over 4, and that's equal to 40. Since we are dealing with time, we have the unit to be seconds, and this serves as the final answer. With the calculation we just did now, we can conclude that it will take sulphur 4 oxide 40 seconds to diffuse under the same conditions as methane gas. That will be all. Do not forget to subscribe, click on the notification bell to receive updates, and as well drop your comments in the comment section. Thank you.